Hello everyone, and welcome back to the Fluctus Channel. The C-17 Globemaster III was built to do two jobs that are usually at odds with each other. Fly across oceans like a strategic airlifter, then land close to the front like a tactical transport. Developed by McDonnell Douglas and later produced by Boeing, the aircraft became one of the U.S. the Devon Air Force's most important cargo platforms because it can move troops, vehicles, pallets, helicopters, medical teams, and humanitarian supplies into places where larger airlifters may not operate. Its cargo compartment is designed for outsized loads, while the rear ramp allows vehicles and pallets to roll directly into the aircraft. Inside a production line, the C-17 begins as a collection of large sections, systems, wiring, hydraulic lines, engines, and flight controls that must come together with extreme accuracy. The aircraft is almost 174 feet long, with a wingspan of nearly 170 feet. And it can airlift up to about 170,900 pounds of cargo. That means every structural part must be strong enough for heavy loads, yet carefully balanced for flight. Wings, tail surfaces, landing gear, cargo floor, and ramp mechanisms are all built to handle repeated stress. Depot maintenance takes that same precision and brings it into a warehouse-like environment. At major logistics centers, the aircraft enters large hangar bays where crews can inspect the fuselage, engines, landing gear, wiring, skin panels, control surfaces, and cargo systems. These bays are not ordinary garages. They must fit the huge body of the aircraft while keeping technicians, stands, cranes, tools, and sensitive components protected from weather. Once the C-17 is inside, maintainers open panels, check corrosion, inspect fasteners, examine hydraulic leaks, test avionics, and repair worn parts that may have flown through dust, salt air, snow, heat, and combat airfields. Inside Oklahoma City Air Logistics Center and other depot environments, the work may stretch across weeks or months. Panels come off, engines are bore scoped, flight controls are checked, and technicians compare every finding against technical orders. A repair team may focus on one door seal, another on avionics cooling, and another on the landing gear that absorbs enormous force during short field operations. This is how a warehouse becomes a life extension line for a gigantic aircraft. Moving a C-17 around a hangar also requires planning. Tow teams connect bars, coordinate with brake riders, monitor wingtip clearance, and move slowly because one wrong turn can damage a multi-million-dollar aircraft or nearby equipment. In winter conditions, pushback becomes even more delicate. Snow, ice, and reduced visibility force teams to watch traction, tow speed, and communication as the aircraft moves between ramp and hangar. Corrosion prevention washes are another important part of keeping the Globemaster ready. Crews rinse and scrub surfaces, paying close attention to landing gear, wheel wells, hinges, seams, antennas, and underside areas where salt and grime collect. Water, soap, brushes, and inspection lights may look simple, but corrosion can weaken structure and shorten aircraft life. Regular cleaning helps preserve a fleet that must be ready for global missions at short notice. After the wash, maintainers look for trapped moisture, damaged paint, loose panels, and stains that may point to leaks. The aircraft is dried, inspected again, and prepared for the next stage of maintenance. After maintenance, the aircraft returns to its real test. Flight. The crew boards, checks systems, calculates weight and balance, reviews runway performance, and prepares for takeoff. From the cockpit, the C-17 feels like a giant machine guided through a disciplined checklist. Pilots manage engines, flaps, communications, navigation, and cargo conditions while loadmasters secure the back. On landing, the aircraft's thrust reversers become one of its signature tools. They help slow the aircraft after touchdown and can even allow it to back up on the ground. During large mission generation exercises, rows of C-17s launching together show the scale of air mobility when maintenance, cruise, and cargo planning all come together. The hangar may seem quiet compared with takeoff, but every launch begins there, with tools, inspections, paperwork, and crews making sure the aircraft can carry a mission safely. Without that hidden repair cycle, the Globemaster's most dramatic landings, short takeoffs, and heavy cargo flights would never happen reliably worldwide today. The C-17's ability to land away from perfect runways makes it valuable in places where normal cargo aircraft would struggle. Before a dirt strip can receive a Globemaster, the surface must be evaluated, prepared, and controlled. A fire truck spraying a dirt airstrip may seem unusual, but water helps settle dust and improve visibility. Too much dust can blind pilots, damage engines, and cover ground crews as the aircraft rolls. Too little preparation can leave soft patches, debris, or uneven areas that threaten tires and landing gear. Air mobility liaison officers and combat controllers help decide whether a dirt runway can support the mission. They inspect length, width, slope, firmness, obstacles, approach paths, and turning areas. They also coordinate with pilots and ground teams so the aircraft knows exactly where to land, stop, turn, unload, and depart. The runway may be remote, but the preparation is technical. Markers may be placed, radios checked, fire response positioned, and updated so the crew understands the landing zone before the aircraft appears overhead. When a C-17 approaches a dirt strip, the crew must control speed, descent rate, and touchdown point carefully. The aircraft is heavy, and once wheels meet the surface, dust rises quickly behind it. Reverse thrust, brakes, and steering must be used with precision. The pilots want to slow down fast, but not in a way that damages the surface or risks control. Loadmasters and ground teams then prepare to open the ramp, unload cargo, or receive passengers, while engines may still be running. If the mission demands a quick turn, cargo is moved away from the ramp, passengers are counted, and the crew prepares to depart before dust fully settles. This is tactical airlift at work, using a large aircraft in places that feel closer to a forward outpost than a major airport. The same aircraft can also operate in extreme cold. Snow runway testing proved how far engineers could push the idea of prepared surfaces. A fully loaded C-17 used a compacted deep snow airfield built by US. Army Corps of Engineers researchers near McMurdo Station in Antarctica. The runway was created with heavy rollers, some weighing up to 160,000 pounds, compacting snow into a stronger foundation able to support the aircraft. That work took more than 16 continuous months and produced a dense layer deep enough to handle the impact of landing. For the crew, landing on snow means trusting engineering before aviation takes over. Braking action, visibility, temperature, and runway strength all matter. For commanders, the result is access. A C-17 that can land on dirt, ice, or compacted snow can bring people and cargo into places where paved runways are damaged, unavailable, or too far from the mission. This is why the Globemaster is more than a warehouse aircraft. It is a bridge between a major airbase and the rough edge of the operation. Its short-field design, thrust reversers, high-lift wing, and rugged landing gear make that bridge possible, but every mission depends on preparation safely. The C-17's cargo bay can carry more than vehicles and pallets. It can deliver fuel, boats, and paratroopers into the mission area. One of the most demanding examples is the aerial bulk fuel delivery system, using fuel bladders and support equipment. Before loading, crews inspect the bladder, prepare straps, position pumps or hoses, and calculate weight distribution. Fuel is heavy, and liquid can shift if not properly contained, so the load must be secured carefully. Filling a fuel bladder is a slow, controlled process. Ground teams connect hoses, monitor flow, check for leaks, and ensure the bladder expands correctly. The system is loaded into the C-17 using rollers, forklifts, winches, or ramp procedures. Inside the aircraft, loadmasters secure it to the floor, check clearances, and prepare paperwork that confirms weight and balance. AFCEN's first aerial bulk fuel delivery system mission, in its area of responsibility since 2017, showed how airlift can move fuel to forward locations where ground convoys may be slow, exposed, or impossible. Fuel drop missions push that idea even further. Instead of landing, the aircraft can release fuel or supplies by parachute to forces below. The ramp opens, the crew confirms the drop zone, and the load exits sequentially. Air delivery allows commanders to sustain units beyond road networks, mountains, rivers, or hostile areas. Each drop depends on wind, altitude, speed, rigging, parachutes, and timing. The C-17 can also deliver boats using low-velocity airdrop systems. A special boat or maritime package is rigged on a platform, restrained inside the cargo bay, then released over water. Parachutes slow the descent so the load can reach the surface with less damage. For special operations or maritime missions, this can place small boats close to where teams need them without using a port. Record-setting drops show the scale of the aircraft's air delivery role. During a jumbo drop, multiple heavy platforms leave the rear ramp, one after another, demanding exact spacing and aircraft stability. Loadmasters watch cables, extraction parachutes, and release sequences while pilots maintain the correct flight path. Large-scale paratrooping adds people to the same cargo logic. Soldiers stand in lines, hook up static lines, check equipment, and wait for the green light. When the doors open, the noise increases, wind enters the aircraft, and jump masters control the flow. Paratroopers exit quickly, one after another, turning the C-17 into an airborne gateway. From depot hangars and corrosion washes, to dirt strips, snow runways, fuel bladders, boat drops, heavy cargo, and paratroopers. The Globemaster is built around movement. Its power is not only in flying, it is in landing, kneeling, reversing, unloading, and launching people or supplies exactly where they are needed. A gigantic repair warehouse keeps the machine alive, but the mission begins when the ramp opens and the world's problems start rolling out of the back. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time, safely.